Welcome back. So in this video, let's talk about how we handle collisions. So when we have a hash function, whatever it is, and we have a lot of data, it's pretty likely or very common that we will have some collisions. Even if we're working with huge data sets, we have a great hash function, we'll still have some collisions. But we're doing none of that. We're working with a small hash table and a bad hash function. So we are definitely going to have collisions. So how do we handle them? There are many strategies for this, but I'm going to talk about two of them here. Separate chaining and linear probing. So let's start by talking about separate chaining. What happens here is basically we just store the pieces of data at the same spot using another nested data structure. So it could be another array or a linked list or something else, but we just store them in tandem. Or does tandem only apply to two? We store them all together. We joint store them. So we can store things, multiple key value pairs at the same position. So for example, if this is our hash table, let's say it's empty. We hash dark blue and we get 4. So we're going to put that right here. But then we also hash salmon and we also get 4. And we also put that right there. Notice that it's in a nested data structure where we have the array bracket here, goes all the way down to here. So they are stored together. This is the first item. This is the second item. So if we were trying to, I don't know, if someone asked me, what's the value for salmon? Well, we would hash salmon. We get 4. So we go to index 4. And then we just loop through. We look for salmon in this list. We know it's here somewhere, but there could be 10 things here. So we find salmon. And once we find it, then we get the corresponding value out and return that. So that's one strategy. We store things together. If we're using an array, it's easy to just use what we'll do, a nested array. The second strategy that we're going to talk about at least is called linear probing. So linear probing is a bit different. We only store one piece of data at each position. That's the rule that we try and live by. And what we do when there is a collision is we look forward ahead for the next empty slot. It is a little more complicated, but it does allow us to not have data stored at the same index. We don't have to store things in a nested structure. So for example, if we have an empty table again, we do dark blue, we get 4, well, we put that at 4. But then we do salmon, we get 4 again. Well, we're going to look at 4, there's something there. So then we just look for the next empty slot, which happens to be 5. So we could store it there. Then we do tomato, we get 4 again. So we look, is there something there? Yes, so we're not going to store it there. Look for the next one, is that empty? Nope. Look for the next one, is that empty? Yes, so we store it there. So that's how linear probing works. So just to recap, linear probing involves storing one thing at each position, and it means looking ahead, or you could look backwards as well, but it's easier usually to look ahead to find an empty space to store something. And that's different than how we handled it with separate chaining, where we store things together in sort of in a nested data structure. So we're going to implement separate chaining in our hash table. It allows us to have, more data than the length of our table. We can store more than 10 things in this table. When we talk about linear probing, though, this only allows us to store 10 things because we're only storing one thing at each position. Soon we're going to run out of space, and then what do? Do we remove things, or do we combine it in some way with separate chaining once the whole table's filled? Do we grow the table? There's many options, but we're going to go with separate chaining. But I just wanted to show you there's also linear probing. Okay, so 2 strategies for handling collisions. Now that we've got all this basic stuff out of the way, explaining what hash tables are, writing a hash function, we have that done. We've talked about how we're going to implement or how we're going to approach collisions. Let's now implement our class and actually write the code to make this work.